would like to introduce the first speaker, which is Angelo Corsaro. He's the CTO at ADLINK and a leading expert in edge and fog computing, and highly active in the research areas of high performance and large-scale distributed systems. And with no further ado, Angelo, the floor is yours. And please stick to your 10 minutes if possible.
Absolutely. Thank you very much. So as we have just 10 minutes and actually a talk that should take hours, I'll try to condense that as well as I can in 10 minutes. So let's get started with trying to understand which problem are we facing today, and sometimes I think which perspective we are missing at today's. So the first point of reflection I would like to raise is one question: the cloud or the internet? Because we see over and over people talking about cloud computing. Yes, indeed, cloud computing has made it easy to provide a very large class of internet services, but yet we shouldn't confuse what brings value, which is the internet service, like let's say cloud storage, right? Or let's say an internet storage service, with the specific architecture that was used in order to provide that internet service. And so I think it's very important, and especially as we move forward, to distinguish between what is the service, okay, and inherently what is the functionality it provides. And once again, if you think about storage, or what today we call as cloud storage, that could just represent conceptually an internet storage service that doesn't necessarily to be implemented following a cloud-centric architecture. I think that's essential because this is what will unlock, I think, innovation and what will allow us to look at problems slightly differently. So let's not tie the specific architectural solution with the innovation we are trying to bring, because there are several different ways, perhaps, of bringing services like storage being something that everyone is aware of. So from my perspective, and as you will see for the rest of the talk, what really matters, right, is the internet. And I think that the way forward is really going back in a way to the philosophical foundation of the internet, which is decentralization, as we will see, and we will see how that will help, I think, Europe innovating and getting forward. So if we, for a moment, try to understand what's the problem today with cloud computing, there are a few. Well, I'm not here to talk about Snowden, because obviously the press gave it huge coverage. But what I want to raise is some problems that, in my experience, are not very well known. So as of today, and you're very welcome, I will have references in the slides at the last page. As of today, any data center, and for that sake, most of the x86 or Intel-based x86 processor are exposed to microarchitectural data sampling attack. Those attacks allow unprivileged user to actually steal data out of a running processor. And so it doesn't matter, what kind of separation technology you use VM, you use container or whatever. Through this attack, data can be stolen as far as you are running on the same host. So it's surprising, because this kind of attack, of which Fallout, there is now workaround, but other which are quite easy to exploit and dangerous, haven't received so much coverage. And the only way today to impede some of those is, for instance, to disable hyperthreading. So you just throw away performance. Other architecture that are more used on the edge, like ARM, don't suffer this attack. And I think are essential, because here we are putting at stake, obviously, our security. And I think this is not the point that is debated as it should, I think, today. The other point that I want to raise as a challenge that comes with cloud computing is monetization. So as a consequence of cloud architecture today, the lion's stake in monetization and control of data is in the hands of a few. And as a consequence, as individuals, or if you think any data producing entity doesn't get a chance to have sufficient control, have arguable ownership of the data, right? Because it's not always clear, even when you use your Fitbit, what you are subscribing to. And as a consequence, you are not given even a chance of, let's say, monetizing your data. And I think this is what really needs to change going forward. Let's get to energy consumption. There are a few studies and some initiatives. Almost all the images on my presentation are clickable, and you will get to the source of the reference, because I think it's always important to give reference. But 2 points I want to raise. One is the SHIFT project. The SHIFT project has been investigating the energetic impact of the internet, and especially of usage of the internet today for what concerns data center, the network portion, and then our terminal. And just to give you an idea of how much energy we are consuming, some of which is a consequence of the media that transfer the most over the internet, which is video, but other, which is a consequence of the architecture and the technology we use to actually communicate over the internet. But just to give you an example, I don't know how many of you know that the video for Despacito reached a very famous hit in April 2018, which was the first video to hit 5 billion views on YouTube. But in the process, it consumed as much energy as 4,000 houses consume in 1 year in the United States, okay, which are not necessarily known to be the most parsimonious country on earth. So that's kind of crazy on one hand. And so projects like the SHIFT project said, well, yes, people keep looking very silly content, so we should develop some sort of collective conscience and reduce our use of video. Sure, right? I agree that having some parsimony on how we use media and how we use any kind of resource, because resources are limited, and that's part of the education we give to to our kids and future generation. But there is another problem. I mean, parsimony always helps, but if we have structural challenges in the way in which we share and distribute content, right? Parsimony alone won't help. And actually, we can't excuse lack of innovation in certain area with parsimony. We need to innovate and we need to solve some of the structural problems that are there. So I think that the cloud computing in Europe, HCloud report summarizes some of the challenges quite nicely. And I'll try to explain how I think we can address most of those. So the first step from my perspective, and again, it's not just my perspective, I think there is a wide community of researchers and technologists that agree with this, is that we really need to get back to distributed systems, okay? So decentralization and distribution is key, because that will allow us, well, first of all, to have much easier control with respect to our data, right? My data stays as close as possible to me. As soon as I do that, not only I have control with my data, which means privacy, which means also reduce energy usage, because I'm not shipping data across the world and then taking it back from the other side of the world to look data that are produced, which is kind of insane, but that's what we do today. And at the same time, all of a sudden, I'm in control potentially of the architecture I want to use. So perhaps even securing this data and having secure data in cloud will become easier, either because I don't allow a third party to execute code on my hardware, okay, or perhaps I use hardware that doesn't suffer the exploit I was mentioning before. And again, sometimes people confuse the facility that the cloud provides with respect to providing things that look like internet service, right? Like, as I said, storage, with the technological innovation required to do the same things in a distributed manner. But that's possible, and I'll show you some example going forward. So what we have done a couple of years, 18 months ago, is to establish an edge native working group within Eclipse IoT, in fact. And we have been working with a major European company, because these are, let's say, open source project driven by European company, to establish an horizontal infrastructure that will provide a completely distributed data plane for next generation internet services and a control and management plane, okay? So I cannot give the detail, but for instance, implementing application like a completely distributed data storage service is now possible, okay? And that gives you full control while maintaining the same abstraction that you would have if the data was kind of centralized in the cloud. So I think open source is the way to go, because it allows us to share investment, to share risk, and at the same time, to lower the barrier of access, which has been one of the challenges identified. So in short, completing my presentation, I think in 10 minutes sharp, the way forward is going distributed. And I think Europe should innovate, not so much engaging with the GAFAM, because I think we are too late on that area. We should just disrupt them and make them obsolete. I think that's the way forward. And that's the way forward, to build economic interest, European economic interest, digital sovereignty, and sustainability. Thank you very much for your attention. And as I said, all the references of the data that I provided are in my slides. Thank you.
Thank you, Angelo, and thank you for sticking to the 10 minutes. I haven't seen any questions in the chat, and according to what I see here, nobody has raised his hand, meaning we can go to our next speaker, which is Klaas Wierenga. Klaas is the CTO of GÉANT. His background is in identity, mobility, and security. And for everyone who doesn't know, he's the inventor of Ethereum, which we probably all are well aware of. And then, Klaas, the floor is yours.
Yes, good morning, everybody. I want to follow on a little bit more concrete on one particular aspect that Angelo was just talking about, and that is first of all, I completely agree with that. Cloud is not different from the internet. It's one of the services on the internet. I may disagree a bit on the distributed versus decentralized, so that is maybe something worth discussing afterwards. And the reason why, in the context of authentication and authorization, I'm not entirely convinced about distributed is that trust doesn't scale. If you look at all examples of trust infrastructures, then research shows that up until, say, 150 entities, you can scale trust. Beyond that, it becomes hard. So when I look specifically at authentication and authorization, we do typically look at a decentralized system. But going a little bit more into what I have seen happening in the past 20 years or so, probably, and I would argue that the same holds true for cloud applications, is that we have learned that it doesn't make sense to do your authentication and authorization locally to the service. What we very early started doing is take the authentication part and later also authorization, even though that's a lot harder, out of the application. And the latest thing that we've been doing by now also for well over 10 years, I think, is doing cross-organizational authentication and authorization, and also known as federation. And I think that evolving ecosystem is something that the cloud world is also in desperate need of. And why would you want to do that? Why would you delegate authentication and authorization to a third party? Well, many reasons. It is never a good idea to start storing personal information about users all over the place. It makes it very hard to keep it up to date. How do you make sure that changes that happen are also replicated on all the other sites? How do you make sure that when you revoke somebody's rights, that all of the decentral services are aware of that, etc.? But for me, privacy is a very important thing that plays a role here. And by centralizing the knowledge about a user allows you to much finer grain control what third parties are able to learn about a user, and privacy and minimization of sharing of personal data is a very important one, of course. But there is one other reason why I think it's very important, and through my narrative, I think it does shine through already, but I want to call it out here very explicitly, and that is, I think when we talk about the internet, pretty much everything is about scaling. And maybe it's not the only problem, but I definitely do think it is by far the most important one. Whenever we start thinking about services, we have to start thinking about how would this scale if it becomes a success. And that is where I've sometimes seen it go wrong in a cloud environment, where a solution that works for numbers in the hundreds doesn't automatically scale to solutions in the thousands or 10,000 or even millions. And so federation is important, and I use here an example that I created way back when I was at Cisco, and then we were looking at these federation relations. And to give you an idea, every one of these federation relations with all of the suppliers in Cisco's ecosystem, we calculated that would approximately cost $30,000 to establish in manpower, legal fees, etc. I'd like to think that in Europe it could be a bit less than that, especially legal fees in the US are sky high, of course. But this is a significant investment, setting up all these relations with all of your suppliers and vendors, etc. And that brings me to the next step, and the thing I think we really should consider in this cloud ecosystem that we're looking at in Europe, and that is the fact that the same holds true for all of these other organizations as well. So they are all replicating that effort, all putting in place these bilateral agreements, etc. And that's why I think we need to be looking at multilateral federation. And a multilateral federation is very much looking like this decentralized system that you've just been hearing about. It's the whole idea is that organizations form coalitions of the willing, if you want, where you agree on a common technical framework, a common policy with respect to trusting each other, agreement on technical standards for interconnecting, all these kind of things. But the basic idea here is that the technical part of getting a user belonging to one organization accessing a service in another organization is solved. Everything that is, well, all that is left to do is the business arrangement, if you want. So if there is a fee included, it means that that you will still need to set up a contract, but you don't have the technical integration difficulty that happens, and that needs to happen. Sorry. So luckily, such a thing already exists, and in the research and education community, we have GÉANT that connects close to 70 identity federations all over the world to each other, allowing users from over 3,500 organizations accessing thousands of services worldwide, including some of the big science experiments like the Large Hadron Collider, the Square Kilometer Array, the LIGO, gravitational waves, and those kind of things, where it's really important to work globally together. And I think here this is an area where the R&E community is definitely ahead of the wider world, and that's not so surprising, because in a commercial environment, you are each other's competitors, whereas in an R&E environment, you are more collaborators. And so that spirit is much more part of the whole picture. So as my final slide, this whole principle of having a federation of federations that allows users from belonging to an organization in one federation to access a service in another federation, we have adopted also for the EOSC architecture. I am chair of the EOSC AAI task force and a member of the EOSC architecture working group. That's why I pretend to speak with a little bit of authority here. So we're looking at precisely this design pattern where we bring in identities from EduGAIN, but also from other identity sources, provide an interoperability layer that allows all these services to be available to the users and have a business layer then that stitches them together. With that, I thank you. 8 seconds over time.
Thank you, Klaas. Very informative, like also Angelo's presentation. As for you, there's no question at the moment. No one has raised his hand. So we can go to the next speaker, which is Leire Orue-Echevarria from Tecnalia. She's a project coordinator there and an expert in software engineering principles for cloud and cloud security certification. Leire, can you hear us?
Leire, I think you're muted.
Yes.
I was muted, yeah.
Yes, perfect.
Yeah, sorry. This is the 2020 joke. Yeah. Okay, so
yeah.
I hope you can see my presentation correctly.
Yes,
right?
all good.
Perfect. Okay, so I will be speaking about Cloud Edge Continuum from a different perspective, more from the applications point of view than on the infrastructural point of view, let's say. So I will start by defining what is a self-healing application. You can also find the name self-adaptive, self-aware, but in the commission work programs and so on, you will see a lot the word in self-healing applications. So that's why I'm using it here. So self-healing applications are those that are able to react to either situations or can foresee potential situations that may prevent them from working in an efficient way. So, and they are able to react themselves and to reconfigure themselves in an automatic way without human intervention in principle. For an application to be self-healing application, it needs to detect failures, but also to foresee that something is going to happen either on the application itself or on the infrastructure. Of course, to detect these failures, they have to log these failures and also treat the different data. And also it needs to have some kind of strategies to see how to react to the different failures. It's not the same a performance failure than an availability failure, for instance. So everything should have some kind of intelligence there. So we are now in the context of the Cloud Edge Continuum, and in this continuum, what we have is some resources and some services that are at the edge, that have some characteristics, some non-functional characteristics. Then you have the cloud computing services and resources or offerings. And you have the transmission between edge, cloud, and also IoT devices. So So what we have here when you want to deploy an application on a cloud continuum solution, well, you have several infrastructure elements. So you have, as I say, IoT devices, you have infrastructural services like an IaaS or a hyperscaler, and you have also another cloud services or edge services. So you have a lot of elements that need to be composed to have a self-healing application and how do you say, yeah, some and always to ensure this the business continuity. Then you have elements that are dynamic. So you have here different resource allocation techniques. It's not the same to allocate something on an IoT device with resource restrictions than to allocate a service or a component of an application on a cloud service. And then in this space, you also have some elements that produce data, and you have some elements that consume data, and they need to collaborate. And for these to be achieved, you need some kind of federation to manage all these aspects. Which are the challenges? Having set the context, which are the challenges that we are facing? So first, as I said, you have a lot of services, a lot of resources. So you need to have some kind of, you cannot select all these resources and all these services in a manual way. You need some kind of intelligence, because you need to have some algorithms or whatever that explains you, that tells you how to allocate each component of the application to each resource and under which technique. As it's not the same to deploy a container on an IoT device and to deploy it on a cloud service. So the technique that you will need to encapsulate the container has to be different. You have to use some kind of lightweight containers or something like that. And then you have to optimize how you are going to allocate these resources. Here, you have a lot of variables that change over time, in the sense that you have a network, you have elements that fail, you have services that don't comply with the SLAs. And with all those inputs, you will have to act accordingly and suggest, for instance, a redeployment. Then we have different models for the deployment and governance. Here in the IoT devices, we don't have capacity for hosting any kind of federation properties. On the edge nodes, for instance, we could have these capacities, these federation capacities, but of course it depends on the kind of edge nodes that we have. In the case of edge nodes, we also have the aspects of the scalability, depending on the services that we are using in the edge, of course. But in the case of IoT devices, scalability is not a finite resource. It's something that it's limited. And also, here we have the sharing of the data between the different resources and also with external consumers. In the case of the cloud continuum, we also have some kind of heterogeneity of networks. Standalone services can have network requirements for the data sources, which may be achieved through technologies such as network virtualization functions and software-defined networks. And here, once we redeploy the application and search for new services, cloud services or private service, we also need to include a configuration of the network. And it is especially important in the case of cloud and edge continuum applications that the topology of the networks may change constantly, also because the devices move And we have application requirements that vary within the same framework, and we have quite a dynamic system. Another challenge is the microservices management. So usually self-healing applications are built as microservices. So we have here to decide how to manage the different microservices, and we have here challenges associated to the movement of services along the different levels, sensor, and cloud, and the automatic adaptation of the execution of the microservices should consider the deployment location, edge, IoT, whatever, also geographical location, context, but should also have into account the resource constraints that may exist in each of the different levels of the cloud continuum. Another important challenge that we have here is the data management and portability at runtime. So here we have to design some kind of deployment policies, some kind of architectures and procedures to accurately manage the full data life cycle. Here we need to take into account the trade-off between the placing data and services on the edge level or on the cloud level, and also how to move it on the fly. There are solutions like containers that allow the portability of stateless components, those that do not have any data, to move them from one service to another service without human intervention or very few human intervention. But in the case of data, stateful components, this is much more challenging, because here we have to maintain the integrity of the data. The application also needs to be available. So yeah, it's a very, very complex problem with a lot of variables. And then we have, as I said, since we are developing self-healing applications, we need to monitor the different conditions. So we have to proactively monitor the edge, the cloud resources and the things. And here we can about availability, performance, location, and any other non-functional requirement that we consider appropriate. We need to be able to predict failures, and we will do that. We should do that with some kind of machine learning algorithms. We need to learn from historical failures and try to predict whenever a degradation of the system is happening, predict which that the system is going to fail. And then we need to implement these self-healing mechanisms, these different strategies. Maybe we do not want to redeploy the whole application, but only this module that failed, but is still maintaining conditions, the preconditions and constraints that we identified. So this is this kind of strategies, self-healing strategies are also very, very challenging to design. And finally, in order to realize this cloud continuum, we have to design and implement some kind of reference architecture. We should define a multiple reference architecture, but one reference architecture with different possibilities. And here, this federation should favor the data sharing, the federated catalog of services, the operational aspects, similar to the ideas of the European data strategy that was released in February. And then be careful also that when we apply federation concepts in the cloud and the edge, we have to take into consideration the pervasiveness of the technologies. We need to manage the resources in a more intelligent way, in a more comprehensive manner, and ad hoc solution, more, as I said, more generalized, and yeah, and in a more deterministic way, I would say. And yeah, this is the end. So any questions are more than welcome.
Thank you, Leire. So there was one question in the chat, which is a bit more widespread, and I actually had something very similar in mind for the panel discussion. Mm-hmm. So it's about the interoperability of edge clouds. And I would like to keep this for the panel because I believe with the expertise of the 4 speakers, it would be a nice panel discussion, this particular topic.
Okay, perfect. Thank you.
Great, thank you. Okay, so so we have now 10 minutes left for a short panel discussion. As I expected, there were quite a number of very interesting points, and the questions I prepared are more or less obsolete now. Nonetheless, there was one thing which also is a bit aligned with the question you got from the audience about the interoperability of edge clouds, and if this will be a service, and what work has to be done for that. I would like to ask the panelists here. I mean, my background is the telco world, and we're talking about the telco edge. So basically, bring the edge, the IP value chain, especially of the edge, into a telco world, which at the moment is, only accessible for the big players.
Can't hear you.
Sebastian, we lost your voice.
You said telco and then we lost your voice.
Sebastian, we don't hear you.
Yeah, and we don't see him as well.
Okay.
We lost him.
I think, I don't know if he still online. We lost the video.
I think we lost him. So maybe,
yeah.
Yes, sorry.
maybe we
So my Zoom stops working every 10 minutes.
Oh, okay.
Yeah. So so my question is, if we want to enable the continuum also into the telco world, that the edge basically spreads across various domains essentially, what is required to enable this? Not just really from a technology perspective, which obviously open APIs, certain open source virtualization technologies, everything should follow a common standard. But what is your opinion where the real challenge is for such a spread of the edge? And maybe to go through the order of the presentation, Angelo, to start with you.
Okay, so, well, honestly, I don't think we can neglect technologies, because if you try today to really implement this continuum, it's a mess. Because I mean, there were several presentations talking about interoperability. Yeah, interoperability, because today, if we try to have this continuum, it's a patchwork of technology to be to put together, because there is nothing that was really thought to begin with to support the use case. So from my perspective, we have to start ground up, having, as I said, first of all, an end-to-end data plane, because today we have a network at a network level, right? As you get closer to device, you might have, in the case of car, vehicular networks, or perhaps low power personal network. Then we have more traditional internet technologies, right? But as of today, if you try to have end-to-end from cloud to device communication, there isn't a single, let's say, data sharing technology that can work end-to-end. So we really have to start providing that level of end-to-end abstraction. And so there are initiatives that exist on that area. The other point is, I think there was an important point about data in motion that addressed. Today, the other big fragmentation is, there are technology for that at rest, there are technology for that in motion, but the two don't mix very well. So that's another aspect where we need really to come up with a unified set of primitives to deal with both, because in this kind of system, because of several reasons, one of which is inherent dynamics, you have to deal with both of those. And likewise for then eventually provisioning computation, a very interesting presentation from the last from Harald. But containers remain still very big, and you can't necessarily provision a container over a low power one. So I think there are still major technological challenges that then complicates the use and deployment of this technology that make interoperability, that makes security issue. So I really think we have to go, start foundationally with the right abstractions, the right technologies, and then everything will become much much smoother.
Yeah. Klaas, do you have anything to add to that?
Well, yes, I think so. And I'd hate to rain on the parade, but I am, to be honest, quite skeptical about this. I think there is a well understood self-interest for the telecom industry to make sure that it is possible to exchange data. That makes a lot of sense. That makes commercial sense. Why would you want to reinvent the wheel every time? Beyond that, I really have a hard time seeing that happen, because back when I was at Cisco, I would usually say we are the gorilla in the ecosystem. And that's what all the big telcos are. They are the gorilla in their own ecosystem. So they will just drive whatever happens, and they will make available what they want to make available. So whereas I would really like to see that I'm wrong, and I hope you all prove me wrong, I don't see that happen. When you compare that to the R&E community, that's another story, because let's face it, a lot of what happens there is because there is funding, and the funding agencies play a role there. The European Commission, the national governments, they play a very important role in enforcing things like open data and interoperability, etc. As I said, I am skeptical at seeing this in industry. But I hope
okay, that's a very interesting point, how much a policymaker like the European Commission or federal governments can actually drive the agenda. Absolutely. Leire, any additional points from you? So we have 3 minutes left, and then I have to go to the summary session.
No, so I think most of my points were actually pointed out by Angelo. So nothing too much from my side.
Okay, Harald, anything you would like to add to the discussion?
I just would support Klaas' view that there's little hope. Yeah.
Okay, then a last question, which I believe is it's very important one, because we see this in the in various communities, the cloud, but also in the operating system community and so on, which is open source versus open APIs. I mean, for smaller companies in particular, where the European Commission has a very strong interest to foster innovation, because they know the innovation comes from the smaller players, not the big players. In order to allow that, open source is obviously the almost wrong answer for an SME to make money, because their business model doesn't allow the scalable aspect. So, but open source, as we see now, look at the Linux kernel, the virtualization technologies, they're all Intel's network drivers. They're all part of an open source, but provided by the big players. So my question is essentially, can Europe become the counterweight to the big players that are mainly non-European, to play a key role in enabling the edge by not necessarily going to open source, but finding a way through?
But my question is, why do you think open source cannot make money? I mean, we were acquired a few years ago, but we were making business on open source, and we were making 10 million per year. I think that's a little bit of money, and good money for an SME. So I think it depends on the business model you have and how you use your open source. Because if you use open source to create a community, and then you provide added value. I mean, there are very well understood models to make open source. And I think that if we consider anything that, well, the foundational infrastructure should be seen as a common good in which companies and the Commission should invest. And it's on this foundational infrastructure that then SME can innovate, right? And then you can have, on top of this open infrastructure for transparency, right? Then you can have innovation and, let's say verticalization that perhaps are commercial. That's my experience, at least.
Yeah, if I may add, I don't think that open source is fine, but open source is not the answer to your question, because just that something is available as open source does not guarantee its it's a market success, and innovations are really uptaken by everyone. So I think open APIs is much more important, and that's also the way of GaiaX. For example, Android is open source, so does it really help small companies? I don't know. Yeah, so I think open APIs and interoperability guarantees are much more important for us and for Europe.
Yeah, I would very much.
Okay.
It seems that we are completely on the same page, the two of us. I would very much agree with that. I don't think that is the relevant parameter to look at. If you look at some of the bigger innovations that have happened in our world over the past 20 years, we're talking about Bluetooth, Wi-Fi, the web, all of them in Europe. So the problem is not that we don't have an infrastructure that allows for coming up with clever new ideas. It's the fact that we don't have an ecosystem that lets the business part of it strive. Because all of those big players, most of what they do is based on a lot of open source that is out there. That's really not what it is about. It's about the business.
Mm-hmm.
Yeah, and with that, I would need to close here because we are running over with time, unfortunately.
Okay, thank you.
Great. Thank you all for your input and the short, but I think quite good discussion. And yeah, thanks for your time and enjoy the rest of your day.